Hi everyone. Today we are going to recap how to explain the trends in reactivity for groups 1, 7 and 0 in the periodic table. You first need to be able to describe what happens to the reactivity of groups 1 and 7 as you go down the group. You need to be able to explain why noble gases are inert, in other words, unreactive. And the tricky part, which is linked to this first success criteria, is you need to be able to explain why the reactivity changes as you move down group. The three groups that you have studied are the alkali metals in group 1, the halogens in group 7, and the noble gases in group 0 or group 8, also known as. The groups are linked to the number of electrons in the outermost shell. We can see that lithium has 1 electron in its outer shell, so therefore it is in group 1. Similarly, fluorine has 7 electrons in its outer shell, so it is in group 7. And neon has 8 electrons in its outer shell. It has a full outer shell, so it is in group 0, sometimes known as group 8. You need to be able to describe the trends in reactivity of each group and explain why, linking it to the outer shell electrons. Let's start with the group 1 elements, the alkali metals. As you go down group 1, their reactivity increases. This means that the further down the group you go, the more reactive the element is. So francium is more reactive than lithium, which is the least reactive alkali metal. Why does the reactivity increase as you go down the group? So as you can see in the image, as you go down the group, the atoms get larger, they get bigger, and so the distance between the nucleus and the outer shell electrons increases. The electrons are held in place by an electrostatic attraction between the positive nucleus and the negative electrons. The further away the outer shell electrons are, the weaker this electrostatic attraction gets. In order to react, the alkali metals have to lose their outer shell electron. They have one single electron, we know, because they're in group 1 in their outer shell and they need to lose this outer shell electron in order to react. The further this outer shell electron gets from the nucleus, the easier it will be for the atom to lose that electron. And the easier it is to lose, the more reactive it becomes. So that is why, as you go down the group, as the atoms get larger, it becomes easier for the outer shell electron to be lost and react, and therefore the reactivity increases. So potassium is more reactive than lithium. Let's check for our understanding. Read through the sentence, pause the video and write down the missing word to complete this sentence. Pause the video for 15 seconds now. You should have got increases. As you go down a group, the distance between the nucleus and the outer shell increases. If you didn't get this correct, pause the video and correct your answer now. Let's have another go. Read through the sentence, pause the video and write down the missing word. Pause the video for 15 seconds now. You should have got weaker. As you go down a group, the attraction between the nucleus and the outer electrons will become weaker. If you did not get this correct, pause the video and correct your answer now. Last but not least, let's read through this sentence, pause the video and write down the 2 missing words. Pause the video for 30 seconds now. You should have got easier For the alkali metals, as you go down the group, the change in attraction makes it easier to lose an electron, meaning the least reactive alkali metal is lithium. Make sure that we read it properly. It's asking you for the least reactive alkali metal. We know that as you go down the alkali metals, their reactivity increases. So the least reactive alkali metal must be the metal at the top of the group, which is lithium. If you did not get this correct, pause the video and correct your answers now, and go back and re-listen to my exposition. Now for the group 7 elements known as the halogens. They are essentially opposite to the alkali metals. As you go down the group, their reactivity decreases. Why is this the case? Why do their reactivity decrease and not increase like the alkali metals? So just like with the alkali metals, as you go down the group, the atoms get larger, and so the distance between the nucleus and the outer shell electrons increases. And just again, like with the alkali metals, that electrostatic attraction between the nucleus and the outer shell electrons becomes weaker. So why does this lead to a decrease in reactivity for the halogens rather than an increase like the alkali metals? Well, when halogens form ions, instead of losing an electron, like the alkali metals do, the halogens need to gain one electron to get a full outer shell. We know they are in group 7, they have 7 electrons, and they need to gain 1 to get a full outer shell and become stable. The bigger the atom is, we know that the weaker the electrostatic forces of attraction, and so this makes it harder for the halogen to attract and gain that extra electron. And this leads to a decrease in their reactivity as you go down the group. This is because it is harder to gain that extra electron as opposed to alkali metals where it becomes easier to lose that extra electron. So therefore bromine will be less reactive than fluorine. Because fluorine is smaller, there is a smaller distance between the nucleus and the outer shell electrons, meaning the electrostatic attraction will be stronger, and so it makes it easier for it to gain that extra electron, meaning it's more reactive compared to bromine, which is less reactive. Let's check for our understanding. Read through this sentence, pause the video, and write down the 2 missing words. Pause the video for 30 seconds now. You should have got harder. So for the halogens, as you go down the group, the change in attraction makes it harder to gain an electron, meaning the most reactive halogen is, we should have got fluorine. Make sure we've read the sentence. It's asking you for the most reactive halogen. We know that as you go down the group, the reactivity decreases. So therefore, the most reactive halogen must be the halogen at the top of the group, which is fluorine. If you did not get this correct, pause the video, correct your answers now, and watch my exposition. Now let's look at group 0, the noble gases. The noble gases are extremely unreactive. A word that we use for this is inert. They do not easily form molecules. You need to know why they are unreactive. This is because they have full outer shells. We do not say that they all have 8 electrons in their outer shell, because helium, which only has 1 shell, has a full outer shell, but we remember in the first shell, for it to be full, you have 2 electrons. So we say that all noble gases have full outer shells. Therefore, they are stable. They do not need to accept or donate electrons, and therefore they almost never form chemical bonds, meaning they're extremely inert, unreactive. Now let's check for our understanding. Read the question, pause the video and write down the answer that you think is correct. 1, 2 or 3. Pause the video for 15 seconds now. You should have got 3. Number 1 is incorrect because they all have stable electronic configurations, meaning they don't need to gain or lose any electrons. This is what makes them unreactive. Number 2 is incorrect because they do not all have 8 electrons in their outer shells. Remember, helium has 2 electrons, so we need to use the correct wording here and not say they all have 8 electrons. We need to say, like in answer 3, they all have full outer shells. Now we are going to have a go at practicing explaining the trends in reactivity. We're going to start with the alkali metals. I will model the first one for you before you guys have a go at doing one independently. So explain in terms of electronic structure why potassium is more reactive than lithium. My command word is explain, so we not only need to state, which it does in the question for you, why that potassium is more reactive, but we need to explain why, referring to its electronic structure. So have a read through my model answer. I have highlighted and underlined the keywords in bold. Making sure that we are using that terminology, electrostatic attraction. We need to link that to it becoming weaker due to the increased distance between the nucleus and outer shell electrons. We then need to link that to, therefore, it becoming easier for the potassium to lose an electron, and link that to it becoming more reactive. Your guys' turn. Read the question. Explain in terms of electronic structure why francium is more reactive than lithium. Pause the video and write your answer now. Let's have a check with the model answer. Should have linked the atoms getting larger to an increased distance between the nucleus and the outer shell. Therefore, the electrostatic attraction between the nucleus and the outer electrons is weaker, and therefore we need to link that to francium finding it easier to lose an electron, making it more reactive than lithium. Let's have a look at the halogens. I will model the first one for you, and then you guys will have a go at doing one independently. Explain in terms of electronic structure why bromine is less reactive than fluorine. My command word is explain, and I need to, in my explanation, be talking about the electronic structure. So just like with the alkali metals, you need to refer to the atoms getting larger as you go down the group, which means that the distance between the nucleus and the outer shell increases. Just like with the alkali metals, this results in the electrostatic attraction between the nucleus and the outer electrons becoming weaker. This is where we need to say something different. So not like the alkali metals, halogens need to gain an electron rather than lose an electron. So if the force of attraction is weaker, this will make it harder for the halogen to gain another electron. So because in bromine the electrostatic attraction is weaker, this makes it harder for bromine to gain another electron compared to fluorine, and therefore it is less reactive. Your guys' turn. Explain why chlorine is more reactive than iodine, which is further down the group. Pause the video and write your answer to this question now. Let's have a look against the model answer and you guys can self-assess your answer. So we should have read the question carefully here. We are not saying why a halogen is less reactive. We are saying why a halogen which is further up in the group is more reactive than a halogen which is further down the group. Like with the alkali metals, we should have referred to the atoms getting larger as you go down the group, leading to the distance between the nucleus and the outer shell increasing. As a result, the electrostatic attraction between the nucleus and the outer electrons will become weaker. Then we need to use this to link it back to the question. Overall, this means that the force of attraction in chlorine will be stronger than in iodine, making it easier for chlorine to gain another electron, and therefore it is more reactive. If you got any of those answers wrong and you were still a little bit confused, then you can go back to the beginning of this video and re-listen to my exposition and have another go at those check for understanding questions and the application questions. Good luck with your practice questions and thanks for listening.